So between today and tomorrow, guys, between today and tomorrow, we're going to try and get through as much of distance formula, midpoint formula kind of stuff as we're going to work through. What I want to do today is start with midpoint stuff. Now, midpoint stuff is actually really, really easy. What's going to happen, though, is that we're going to change it up just ever so slightly tomorrow with midpoint, as well as talk about the distance formula stuff. Tomorrow, it is really important that you guys have a calculator that has the radical button that simplifies for you. Otherwise, you might have to remember how to simplify radicals. I might have mentioned to you guys a few times throughout the course here that it is very rarely that we will ever use decimals. One of the things that we strive to do with you guys is to get you guys accustomed and ready for, ACTs, SATs, all that kind of fun stuff, your Algebra 2 courses and whatnot. And in order for us to do that, a lot of times we want to keep things in what are called simplified radical form. And it's really important that we're able to do that really a lot more tomorrow than it is if at all today. So let's just look at the term midpoint. What do you think, this is going on a stretch here, that midpoint means? Just by reading the word. The middle point, the halfway spot. That's exactly all it is. For example, a typical ruler is 12 inches. Where would be the halfway point, guys? 6. The halfway point, the midpoint of a ruler would be at 6, which means I should be able to balance a ruler level. Is it levelly? Level. I should be able to hold a level, or have it level, thank you. That's why I was never a very good English person. Have it held level at the 6, because half the values are on one side, the other half are on the other. So a midpoint is absolutely nothing more than the halfway spot on a segment. It doesn't technically work on a pencil. Why? It's not even. Because it's not weighted the same. Some parts are weighted. If you think about it, you have this extra counterbalance here, but
oh no, it's not weighted.
well, I'm just if you have a pencil that's mechanical, or even a regular one, just the pencil with the eraser, you might have to hold it a little bit more closer to the back end because it weighs more and all that, just to hold things level. But I'm saying in pure essence, if I wanted to cut something in half, I'm going to find the middle point of it, and I can break it, and that's where it's at. So a midpoint is nothing more, is the midpoint of a segment is a point that divides a segment into two congruent or equal segments. So when we talk about midpoint, we're talking about the halfway spot. Where does the halfway point occur? Where is it located? Excuse me. Now, one of the other things I want to get you guys accustomed to seeing is how you can write this out in order for you to be able to use it again later. For example, a lot of times, as we get going further into this semester, we're going to start to eventually talk about triangle proofs. And within triangle proofs, you have to be able to be given information and take given information and say something about it. Well, I know that if I'm given a midpoint, we'll do an example of this. X is the midpoint of AB. Is it okay that I abbreviate midpoint MDPT?
Sure.
Too many letters to spell. Okay? So I'll just say it's the midpoint when I write it out. If X is the midpoint of segment AB, what are the endpoints of my segment? AB. So on a segment then, I could say the following. A and B. Where do I put X? In the middle. Now, this then means that AX has to equal what? That's all it is. So now you were given the fact that we have a midpoint, which means that it divides it into two congruent segments. Well, that means that AX is the same as, remember those tick marks?
Yep.
That's all it means. So it means they're congruent, so they're equal in length. So algebraically, we could say a couple of things. Therefore, AX is congruent to XB, or AX equals XB. And it isn't the end of the world. We don't have the bars over the A, B's, and all XB's and all that. It really isn't the end of the world. It really isn't. All right. So what's going to happen here later on, we talk about this nasty four-letter word called two-column proofs. And we talk about it in terms of statements and reasons. Basically, a two-column proof is a valid argument using definitions, theorems, and things like that. Midpoint is a definition. When you have a midpoint, you know something can be defined. For example, if I say that X is the midpoint of AB, and I tell you that's a given statement to you, it's given in directions. Don't worry about writing this down quite yet. We're getting to it. I just want to get you the idea of what it's going to look like here in about a month. Because pretty much most things that we define we'll be able to use like this later. If I know that a midpoint occurs, what does a midpoint do? Well, it cuts it into two congruent segments. What, in this case here, what were the two segments that were created? AX is congruent to XB. And the reason that they're congruent is because we just used the definition of a midpoint. That's how this stuff is going to start to flow itself through. What we're going to be able to do with that is that inside triangles, if I want to prove I had two triangles that are congruent to each other, if X is the midpoint here, I know that those two parts would be congruent. And that's the kind of thing that I'll be able to start to say. Okay? So don't forget that even though right now we're just barely talking about midpoint in terms of numerical examples, and here in a second algebraic examples, we're still going to utilize those definitions later to help with what's called proof. Okay? And it takes a while to get used to how this looks. So I just want to give you guys a little forewarning to where we're headed. Another thing that we talk about besides midpoint is something called a segment bisector. A segment bisector is the same thing as a midpoint, but it's anything else besides a point. A ray cuts something in half. A line cuts a segment in half. Another segment cuts a segment in half. That's all it means. It doesn't necessarily always have to be a point. It could be something going through the point. All right? Think about Robin Hood shooting an arrow and he splits the apple in half. The arrow looks like a ray. The ray cut the apple in half. So I don't know, it's kind of a bad example, but you get the idea. All right? It could be anything else that goes through a segment at its middle spot, the midpoint. Like I said, we see segment bisectors not so much as a real difficult thing. A lot of times you'll say that such and such is a segment bisector, figure out what both sides add up to equal. So if I had, let's see, this is segment A, B, and this is ray C, D. What it might look like written out, ray CD bisects AB at point D. That's what that would be written as. ray CD, because it's got the bar with the arrow on it, saying that C is the endpoint, it goes through D. It bisects AB, the other segment, at point D. And that's how you would draw that. Which means that if this segment here, AD, was 18, what does the other segment have to be? What is it? 18. What's the whole thing then? 36. That's it. That's all it means. It's just another way to use the definition. That's all. You're going to see that the math here is pretty quick, pretty painless, but we're just using very simple 1-2-step equations, two-step algebra really, that blends within geometric terms. And that's where we're heading towards. Okay? That's where we're heading towards. Okay? Okay. All right. So we have an example. Here's our example of segment AB, and X is a midpoint. And the kind of questions you're going to be asked is, find the whole thing, find one part, find another part. It's not always just going to be solve for X. Okay. You have to solve for X algebraically, but you have to use the value of X geometrically to finish it out. That's kind of the spin on the algebra here. And I had discussions with, was it first hour? I think it was first hour. First hour was a little miffed the idea of like, well, why are we in geometry if all we're doing is algebra? Well, in geometry, you still have algebraic stuff that makes geometry work. We use algebra to make it work. It's the same thing in most classes. Most math classes past algebra, well, they all use algebra. Just like ever since you guys learned how to add, don't you still add in just about every other math class you've ever done? Don't think you can skip adding in anything. It's always going to be there. Same thing with multiplying, dividing. You know, the whole idea of just solving for X, getting Y by itself, those whole concepts, those things never go away. So, a couple things you can go about doing this. We know that X is the midpoint of AB. Therefore, we know that AX has to equal XB. All right? So what I would do is just write out AX equals XB, and then I just fill in the blanks. What was AX?
4x minus 1.
So 4x minus 1 has to equal, and notice you're back to a real quick two-step equation. Take on the little guy. You have variables on both sides of the equation. The easiest thing to do is always to pick on the little guy. By doing that, you're usually less likely to have to worry about a negative value later on. It's just a little bit cleaner. So what are you going to move, a 4x or a 3x? 3x. Are you guys okay with me moving moving that -1 to the other side at the same time? Just saving paper. Because I run out of paper on this thing. You get, so x is 4. Okay. Now if x is 4, what is each individual piece? Make sure we got it right. Not each piece isn't going to be 4. We just substitute in. What's 4 times 4?
16.
Subtract 1, you get. Now it's always good to double check both sides so you don't just take the one side and double it.
12, 15.
3 times 4 is?
12.
Add 3, you get.
15, 15.
Hey, are those two equal?
Yeah.
That means if they're equal in length, they are therefore congruent. Therefore, 15 and 15 is?
30.
That's all it is. Pretty quick. What's that? Oh, I know. There's nothing wrong with that. There's absolutely nothing wrong with that. Okay? Not terrible? I think there's more work in the stuff you guys did yesterday than there is with this. But then, the other part of it goes with, instead of being within a segment, sometimes you're trying to find a midpoint of coordinates when you're looking at ordered pairs. So the easiest thing to think of is, you got any cash on you? Hello, sleepyhead. Am I that boring that you want to fall asleep every day?
Yes.
Shut up. You got any cash on you? You got any cash on you? You got a 10. All right. Oh, thanks. All right. So he's got a 10, and then I actually have the calculator money. You're right. 2, 3, 35, 40, 45. I have $45 in calculator money, and you have $10. What I want to do is talk about how do you find an average of two values. If you have $10, and I have $45, how do we find the average of that? What do you do? Yes, ma'am. Oh, okay, never mind.
You add them together, then you divide by 2.
Now, do you always divide by 2?
No, you divide by
The number of times you.
the number.
So if there were 3 of us averaging our money, we divided by.
3.
If there's 7 of us, we would divide by. Okay.
It's like 7%.
So what we're looking at here is we're finding what's called the midpoint. We're trying to find the average amount of money between the two of us. So what we do is divide by 2. 2 goes into 5 how many times? Twice. How many are left over? 2 goes into 15 how many times? How many are left over? So we have an average of $27.50 between the two of us. That's the average amount. That's the halfway point between the two of us, numerically. Now, instead of doing that with just one value, an A and a B, what happens sometimes is we have to look at it in terms of ordered pairs, where we have one set of X and Y values and another set of X and Y values. So we have to come up with the average amount of the X's and the average amount of the Y's. So basically it's no more than taking, to find the midpoint of a set of ordered pairs, so I use M for midpoint, it's just the average of the values. You take the first X value, you add it to the second X value, and you divide it by 2. You take the first Y value, you add it to the second Y value, and you divide it by 2.
So is this the midpoint or?
Yeah. It's the midpoint when you're using coordinates. Sometimes we find midpoints with algebra when you have the example before it, but a lot of times we're going to do it with the actual coordinates in space. And then tomorrow I'll show you guys the question that ACTs and SATs ask you all the time about this. It's so stinking simple to go over. It's crazy how fast you can do it. So if I go back to the picture I had there on the graph, it's right there. If I go back to the picture on the graph, obviously you guys don't have a piece of graph paper or anything on there. I'm not worried about you guys graphing any of this stuff, but do you remember how to read ordered pairs? What comes first in an ordered pair? X. Now are X's the ups and downs or the left and rights? Very good. So when I'm writing this down, I have an ordered pair here at -4 and 2. And my other one is at 3 and 6. Now, I picked the -4 and 2 as my first set of ordered pairs. Could it have been my second set? Yeah. As long as you're consistent with the X and the Y's for that ordered pair, you're fine. But to be honest with you, do it the way you read it as you're going from left to right. You'll be less likely to mess something up. Yeah, that's really about all there is to it. Okay? Now, in order to figure out where the halfway point is, all we do is label it. First X, first Y, second X, second Y. And this is where that calculator with the fraction bar becomes so important. because you can do this. You're just using that formula straight in there, and you press buttons on your calculator. You would create a fraction bar, and you type it in. -4 plus 3 over 2, and hit enter. And it gives you the fraction. It gives you the number. It tells you exactly what it is. Okay. You get -1/2 of the average of the x's. Now, before I go to the y values here, watch what happens if you don't use the fraction bar and you're not careful on how you put it in. -4 plus 3 divided by 2. What did it do?
It didn't add.
Yeah. Everybody see how it divided first? What it's doing here is that the calculator, if you don't use the fraction bar, or like Barry, for yours, if you don't use the parentheses, or do you have the alpha y equals? Does yours work if you hit alpha y equals? On your calculator, hit the button that says alpha, and then hit y equals. Alpha is the third button down on the left. It says alpha. A-L-P-H-A.
Actually, it doesn't say that.
Oh, hey, you don't have that. Never mind. And don't negate, just put the -4 plus 3 over all that. So anyway, but see how this one here, it says it's just -2.5? Because it's going by order of operations. It's wrong. Okay? I forget, who had the pink calculator? You just have to be careful with that. If you had, you had the pink calculator?
No, I don't have it.
Yeah, because having a calculator in math class would be
Yeah.
smart to bring with you. You'll have to make sure you do this. Put it in parentheses. But then you have to remember how to convert that back to a fraction. I don't want decimals, I want fractions. Okay. All right. Same thing with the other one. Another one of the fraction bar creates 2 plus 6 all over 2. And there's your ordered pair. Okay. This stuff is really it's very fast, very easy to work with. What's going to happen is that you guys have a tendency, especially starting with this stuff, working with the ordered pairs, to accidentally flip-flop values or miss a negative symbol. Just take your time with it, really. I know that the example that I gave you guys earlier, when I said this, that will come in handy with one of your homework question problems tonight about how to draw a diagram. Okay? So I'm going to stop here because I want to get into the rest of this stuff for tomorrow. The homework, I believe, is on page 19 in the book, and I have you guys doing 8 through 22 evens. Okay?
Why do we want to do
Because anybody can copy on answers. Actually, you guys don't have textbooks. I probably could give you odds because you don't have the textbook to look up all the answers. I haven't posted those. Even though you could probably find them if you Googled it.
No, last year we couldn't find any book.
For the algebra? You didn't Google hard enough because I could find it. It's crazy. I'm telling you guys, when you get going, if you ever go into any really higher level math classes, what's up? Google's your best friend because you can find all of it. Right?
She's up there hanging. My mom knows how to do that, but she does not. So it's only if
Sad.
she can figure it out.